Swayam Prabha. Digital India. Educated India.
Good morning students, welcome to today's lecture. We will continue our journey into the design ecosystem for complex products today. As you will recollect, we are looking at the problem and solution domains in the design process. So, we'll look further into that, and then we will understand the research methods for use in the discovery phase and carry on from there. Okay. So, as you will recollect, there are two key domains. There is a problem domain and then there is a solution domain. In the problem domain, you are essentially doing research, okay, and in the solution domain, you are doing the design. And of specific importance in the double diamond design process is the discover phase, on which there is a lot of emphasis that is placed. So, we will look more into a discover phase and how it plays a key role in product development for complex products. So, we looked at the nature of design problems as them originating as some form of problem statement that is provided to a designer by someone else. We looked at the examples of problem originators, we understood what was a design brief, and we looked at some examples of design briefs. One being from President Kennedy, which was a sentence to land a man on the moon and bring him back safely. Then we looked at an example of a design brief given by managing director of a company to an industrial designer, and that was again just 3 sentences, which just needed a simple design modification to an existing product. Then we looked at something more technical, which was more specific. So, a client looking for a one-handed water mixing tap, and this had some specifications to it, such as throughput, maximum pressure, and so on and so forth. So, 3 different types of design briefs, and we understood what was common among these design problems. So, the first thing was that they set a goal. So, there was a goal, there was an ultimate end objective, there were some constraints. So, you didn't have infinite design freedom, there were some constraints you had to work to. Okay. And there were some criteria to recognize the successful solution. So, these design problems have one thing in common, which is they do not specify what is the solution, and also they do not give you a certain way of proceeding from the problem statement to solution. So, they state a goal, but they do not tell you how to go to the solution, and that is where design comes in. So, you have to apply the design process to go from the problem statement to the solution. So, a person who is setting the problem usually does not know what the answer is. He knows that, well, there is a problem. So, that leads to a goal which we must achieve, which will be the solution, but the person who is setting it does not know how to get there. But when the person who has set the problem will see the solution, they will recognize it and they will be able to tell, yes, this is the solution to my problem. Now, let us come to problems themselves. Sometimes problems may not be very well defined, they may be ill defined, and that occurs when there is no definitive formulation of the problem. So, the problem can be interpreted in many different ways. So, then the problem is ill defined. So, this typically happens when the goals are vague, the constraints and criteria are unknown. Okay. So, the goals are not very clear, okay, and it is just a vague goal, and people do not know what are the constraints and criteria. So, if I told you, okay, go ahead and design a laptop. So, everyone knows what a laptop is, but you do not know what are the goals, what are the constraints. Should I make a laptop that is very fast? Should I make a laptop that is just okay? Is it for use in office? Is it for use in the home environment? Okay. So, when the constraints, the goals and the criteria have some ambiguity in it, so we do not know the goals, the constraints and the criteria, then it is an ill defined problem. Or there might be inconsistencies in the problem formulation. So, the problem formulation may have statements which are contradicting each other. So, that is an inconsistency. So, these inconsistencies will emerge only when doing problem solving. So, the problem may look from the outside as something that is okay, but when you try to solve it, that is when you may find that there are inconsistencies. So, in that case the problem is ill defined and you may have to spend some time defining the problem better. Sometimes you may have formulations of the problem that are solution dependent. So, depending on what solution you have arrived at, the problem formulation itself may change. So, there is a dependency between the problem and the solution. So, in that case also we can say that the problem is ill defined to begin with. So, typically in such cases it is difficult to formulate the problem statement without explicitly or implicitly referring to a solution concept. If you are not able to come out with a definitive problem statement without talking about the solution, then the problem is ill defined. Should be able to talk about the problem without thinking of the solution, only then it is well defined. Also, if proposing solutions is a means of understanding the problem. So, if you propose a solution and that is how you understand the problem, that is also an example of an ill defined problem. So, these proposed solution concepts may expose some problems with the problem. So, in that case the problem is ill defined. Also, there might be some problems where there is no definitive solution. So, there might be different solutions that are equally valid responses to the initial problem. So, if there is no certain solution, there might be 2 or 3, 4, 5, 10 solutions that are equally valid responses, then also it is an ill defined problem. So, we have 5 different scenarios where the problem may be ill defined. So, this is why it is important that we spend sufficient time in the discovery phase, and I will teach you today some techniques which you can use to make your defining the problem easier. So, one of the things we can do is understand the structure of the problem structures. So, here is an example of a problem structure which can create issues. So, there is a roof, there are core partitions on the first floor, there are core partitions on the second floor. So, this is a building where you need to design the roof, the drainage, elevations, etc. And you can see the interlinkages between the different things that you are designing, different elements that you are designing. So, here you can see that the direction of span of the roof will affect the core partitions on the first floor, and also the external walls affect the roof. So, let us say I change the direction of span of the roof to accommodate some issue that is occurring with the construction. We change the direction of the span. So, instead of being like this, maybe we make it slightly at an angle, and then what that does is the core partitions of the first floor change. So, let us say it is a 2-storied building, there is a ground floor, there is a first floor and there is a roof. We change the span of the roof. So, that changes the core partitions of the first floor, and once we change the core partitions of the first floor, then that changes the core partitions of the ground floor. So, once we change the core partitions of the ground floor, since the ground floor affects the roof of the first floor, the top of the ground floor will affect the direction of span of the first floor. So, this is the span of the roof, this is the span of the first floor, and let us say then there is the ground floor below. So, once you change the core partitions in the ground floor, it changes the direction of span in the first floor. So, that means the external walls will change, and the moment the external walls change, then the direction of the span of the roof also changes. So, you change the direction of span of the roof in order to fix some problem in the building. Maybe there was some seepage or other issue, or maybe the wind was blowing in a certain direction and it was necessary. But due to that, you had to also accommodate the design changes to other elements in the building, which in turn changed the direction of span of the roof again. So, this is what is known as a pernicious problem structure, circular problem structure. So, despite progressing into a solution definition, you may encounter difficulties in problem structure. Okay. So, these sub solutions may be interconnected to form a pernicious circular structure. So, the sub solution that resolves a particular sub problem may create irreconcilable conflicts with the sub problems. So, the sub solution to this may create conflicts with other sub problems. So, how can we deal with that? So, one way of dealing with that is using decision trees. So, this is an example of a decision tree. So, here you can see 3 types of indications, one is problem, then decision, and the third is alternative. So, let us say we have a problem with a fastening device and the solution could either be near the front wheel or near the back wheel that you make a change. So, this is to do with a bicycle, and you can see you can make changes to a front wheel or to the back wheel. So, there are 2 alternatives, you can go in either direction. So, you list those 2 alternatives, and then having listed those alternatives, you might find further alternatives. So, near the front wheel, if you want to make some changes and you want to install some kind of carrying or fastening device such as some kind of a holder to your bicycle. So, you might attach it to the front handlebars, you might attach it to the front side, or you might attach it to the front top. So, 3 alternatives. So, if you think of the back wheel, again you might have 2 options, use the side mount or use a symmetric option. So, you can install this fastening device on the side, or you can make it symmetric with respect to the bicycle. And if you make it a side mount, then again whether you want to keep it forward or rearward, 2 options. So, likewise you can break it down further, and as you break it down you take decisions. What happens if I choose the front handlebars? What happens if I choose the behind the wheel? So, is it conflicting with other parts of the bike? So, consider that and keep going until you have decomposed the entire problem. So, higher level strategic decision gradually unfloods into lower level implications and decisions. So, start with your biggest problem and then break it down, and at each stage you may have to take some decisions, whether I want to go in this direction or this direction, and then examine what happens if you go in each direction. So, this is one way of resolving the problem structure. So, what is this known as? This is a decision tree. So, you are taking a decision at each step. So, we started with an overall problem, and that overall problem was broken down into sub problems, and sub problems can be broken down into individual problems. For individual problems you may find individual solutions, for the sub problems you can find sub solutions, and therefore for the overall problem you can then find the overall solution. So, let us look at how you can do your practical project. Okay. Some of you are probably nervous after going through a brief as to how you will do it. So, let us look at this one desktop miniature factory which I worked on when I was in the UK at Queen's University. So, here you can see some pegs. These are some pegs and these are some discs with holes, and they are getting assembled here, you can see. So, the pegs are coming down this aisle, the discs are coming down this aisle, the pegs are coming down from there, and then this disc rotates and assembles to create this peg and hole assembly. You are able to observe. Should I play it again? It is on YouTube as well. I have posted it on YouTube. So, you can have a look if you want to. Let us play it again. So, So, what you can see here is there is a channel through which these are going up a conveyor belt and they are coming down, and there are some sensors. You can see these sensors glowing, okay, and this is a red box. So, if the assembly does not take place, then there is a unit here which will kick them into this box, okay. If the assembly is correct, so there is a sensor here which detects whether the assembly is correct or not, and then it lets them through, okay. Interesting, yeah. So, you might be wondering, well, how can you make such a thing, okay. So, you are just an undergraduate student, you have been given a problem, how will you go from the problem to the solution? So, this is a side on view. So, you can see some extra controls here. So, this is to stop the whole system in case something is going awfully wrong, and again there is an emergency button as well, and you can see the pegs and the discs with the holes going up like this, coming down and then getting assembled and landing here. So, this is a side on view, and you can see there are two chutes, one here and one here. So, pegs are coming down this chute and the discs with the holes are coming down this chute. So, this is known as a bitronic industrial control technology. So, there are PLC controllers that are controlling the whole process. They are taking the sensor input, and based on the sensor input they are deciding whether the peg and the hole assembly has taken place correctly or not. If it has taken place correctly, they let it through, and then you can collect them and place them in the green box. But if they are not correctly assembled, if it is just discs with holes going through, there is a kicker here that kicks them into the red box. So, that is because this capacitive sensor reading will have a reading that crosses a threshold. Once it crosses a threshold, then it knows whether, so based on the circuit here, it might be that if it crosses a threshold, then the assembly has taken place correctly. So, in that case it lets it through. If it does not cross the threshold, then it, and if it is between two values which indicates that it is just a peg or just a disc with a hole, then it will kick it into the red box. So, you might be thinking, well, I am just an undergraduate student, or I am just a master's student, or I am just a PhD student, I am just a student, how will I create such a thing? This is all done in industry, right. So, the way to go about it is, so if you see these parts here, these are nothing but sheets which have been bent, okay. So, you can take flat sheets and you can bend them into any shape using a bending machine. So, once you have done your design, creating these shapes is not very difficult. You just need to go to a workshop, and we will take a trip down there today after the class, and you can just create these bends and you can create this kind of a structure. Everything needs to sit on some kind of a overall base, and then once you have created these things, okay, you have created these alleyways on which these go up, then you need to install a belt mechanism which will need motors to for it to continue going, okay. So, you have to start thinking about what mechanisms I need, what motors do I need, what sensors do I need, what connectivity wiring do I need. So, that way you can break down the problem into simpler problems which can be solved. Okay. So, instead of being overawed and wondering, well, I will not be able to do it, think that it is quite simple, you can do it, at least you can take it to a certain level based on the understanding that you gain here and your common sense, okay. So, it needs, yes?
We did a kind of similar project in our first year.
Oh, really?
TA2, it was just not working.
Okay.
It's just a design project.
No, that is good. So, you have some experience. So, now you can make it better. If you work in a group, form a team, then you might be able to solve it. And then if you are not able to solve problems, then come to me, ask, okay, meet other people in the workshop and other technicians, they will also help you. So, everything is feasible. So, the key features of this control system are that it is completely self-contained. It is a representation of an automated assembly system which you may see in a factory. It performs these operations: sorting, assembly, checking and rejection or acceptance. So, it sorts based on whether the assembly is correct or not. It does the assembly as well. It checks, then it rejects or accepts. Okay, so, these are the functions. So, we are using two types of conveyor systems. One is for that belt that is taking the things up, and the other is the bed on which everything that is assembled is moving. We are using industrial grade sensors with visible indicators. So, there are lights that are glowing and telling you whether it is on or not, and then again they are lighting up to green or red based on whether there is a proper assembly or not. And there are various types of sensors that are used: infrared, inductive, capacitive and fiber optic. So, just exploring a bit into sensors will also help you design such a system. So, going to a library, looking up some books on sensors, some mechatronics books will give you some ideas on what sorts of sensors will help you achieve certain functionalities. So, you have to think, okay, I want to achieve this functionality, what sensor will do it? Okay, then go and explore more on it. So, you need some electric power, 24 volts DC, and you need some fault insertion switches. So, those emergency buttons that you saw, etc. So, the specifications come out like this. So, eventually once you have designed your whole system, you will be able to write out your specs, which are very much numerical and quantitative specs, such as inputs, outputs, okay, what is the chain conveyor like, what is the belt conveyor like, which sensors and how many numbers, what solenoids are used, what are the switch faults, what are the controls in it, what are the connections, and what are the power supply requirements. So, eventually you will end up with this. Okay. So, I am giving you a very specific example, so that it gives you kind of a blueprint to create your desktop factory. So, you do not start off with nothing. So, you have this as the blueprint and you can use that to formulate the ideas in your head. So, even if you are designing a chemical plant or some other, maybe a paper processing mill, whatever it is that you are thinking of, it can be very simple as well. 2 or 3 operations with some sensors that are measuring some flows and then passing that data onto the smartphone. So, whatever it is, so eventually you can, so to get there you can use this as your blueprint. Right. So, now let us get back to our discovery phase. It might seem like going off a bit on the tangent, but the discovery phase is really crucial when we are developing complex products. So, what are the research methods we can use? So, there are 2 types of methods. One is known as creative methods, okay, where you use your creativity, and the second is rational methods, where you use known scientific techniques. So, these creative methods help stimulate your creative thinking, they increase the flow of ideas, they remove your mental blocks that inhibit your creativity, and they widen the area in which a search for solutions is made. So, you use your creative thinking to do the research, and we will see what these creative methods are. And then there are rational methods, they encourage a systematic approach to design. Your approach to design is very much pragmatic and follows a system, and therefore, you use techniques that are well established. So, we will look at both these types of methods. So, first creative method is brainstorming. So, after the class today, you can come with me, I will show you a little area in a design studio where students come around to do brainstorming. So, this is a typical brainstorming session. People sat around in a group and with tea and coffee and some drinks and with their laptops and sketch pads, notepads, etc. They have got some data, etc., which they are collectively looking at. So, it is a method for generating a large number of ideas, most of which will be subsequently discarded. So, that is brainstorming. So, you come up with a number of ideas, many of which may be strange, but eventually maybe you might come up with one idea and few novel ideas which may need follow up. So, typically a brainstorming session is a small group session of 4 to 8 people, just like the groups you may form in this course. So, if I may ask at this point, how many of you are going to do this project individually? How many of you are going to do it in a group? Okay, so have you formed, how many of you have already formed your groups? Okay. So, those who have not formed your groups, I encourage you to talk to each other, see if the frequency matches, or if you want to join one of the groups that is there. Okay. So, after this class, do not run away and talk to people. So, see if you find some synergy with somebody. So, there are some rules of brainstorming. The first rule is that no criticism is allowed during the session, do not shout at each other. So, encourage these ideas to flow, okay, do not call each other stupid. So, no criticism is allowed during the session. We need a large quantity of ideas. It's not 2, 3, 4, 5, maybe 20, 30, 40, 50. Okay. We need a large number of ideas. Seemingly crazy ideas are quite welcome. Okay. So, if you have a crazy idea, that is all right. You need to keep all your ideas short and snappy. So, just a brief pitch about your idea, do not go on and on. Try to combine and improve on the ideas of others. Okay. See if you can take some ideas and combine them. So, maybe person A says something, person B says something, maybe then combine A plus B and come up with an idea. So, do not be disappointed if your idea is struck down by a group. So, think about it. Okay, maybe in the heat of the moment people are saying something. So, keep it in mind and let it evolve in your head. So, and maybe you can come up with a nicer justification the next time you meet your group. The key is do not criticize. Okay. So, that is key. So, try to combine and improve on the ideas of others, and that will help you develop the solution. So, let us look at an example. Okay. So, if I give you a problem of providing a means for securing containers that is tamper proof, but easy to open. So, think of a means for securing containers that is tamper proof, but easy to open. Does anything come to your mind? So, tamper proof means if you have secured the container with some kind of a lock, then if somebody has done anything to that lock, then you will get to know. A bolt. Okay, a vault. Okay. So, how will you find out whether it has been tampered or not?
Like we can place a sensor. Like the sensor feels a strong force or like a strong impulse around it, and then it can we can place. I think like it will shake. The sensor will know it is shaking. So that's why we are like able to know.
So what if you are transporting this container? It will shake without any human intervention.
No, the security means that like we need to like give the information if the box is getting opened.
Okay.
Yeah. So like we can have the fingerprint or suppose number lock in it. So if the number is wrong, then we'll get the information.
Okay. Somebody tries to change the numbers that was originally there, then if that information can be conveyed. Okay. Okay. So that might be a solution, but that might be difficult to implement also, because if the number changes, how will that, and the number, let's say it changes due to.
We can make it a digital keypad.
Okay.
Not the analog one.
Okay. So yes, so there might be such ideas. Okay. So let's look at what were the ideas people came up with in a brainstorming session. So like some of you suggested combination lock, somebody suggested a time lock, another person suggested incorporating an electronic code and faxing the code to the recipient, and so the recipient would know the code and be able to open it. So that is tamper proof. So even if somebody tampers it, he will not be able to get through. You can have clasps which are welded together. So if you somehow take the welding off, then that's indication that it has been tampered. Locked bolt that is easily cut to open it. So another suggestion was to use padlocks with master keys which are retained just by the customers. A giant stapler and a staple remover, a ceramic bolt that can be smashed. So it has to be smashed, otherwise you can't open the container. A glass cover that sounds an alarm when smashed. A lorry driver that swallows the key. So this is again something, it's a funny solution, but you shouldn't criticize it. Okay. So because it's a brainstorming session. Okay. And a puzzle lock that can only be opened by a very skilled person. So unless you are skilled enough to solve that puzzle, then you will not be able to open the container. So these were some of the ideas that came out. So the solution that was finally devised by the company and accepted was this sort of a container lock. So it was a bolt that was designed to be cut off. So only when you cut it off that you can open the container. So it was made in two sections. The part of the bolt would be pushed together. The parts of the bolt would be pushed together to secure the container and could be only opened by being cut only when you cut it that you can open it. There was color coding and numbering of each bolt, that meant that nobody could replace it in transit, and if it was cut open then it would be obvious. So, this is known as the one seal disposable container lock, and it was based on certain key principles, which was a locking device that had to be cheaper than a padlock, but with the same security, or a padlock intended to be opened by a bolt cutter. So, basically it was also meant to be cheaper. Yeah, so, that was one of the constraints on the design, otherwise some of the crazy ideas would have made it, okay, like the electronic code, etc. It was a mechanical solution and was such that it was tamper proof. Hologram. And how will that work?
The hologram is tampered, they cannot put a sticker there.
Okay.
The company alone has the control.
Okay. Very interesting. Okay, that's an interesting suggestion. So, using a hologram that if tampered then it will be evident. So, another creative method is synectics. So, what is synectics? It is a group activity in which criticism is again ruled out, and the group members attempt to build, combine and develop ideas toward creative solution to a set problem. So, maybe there are 4 people A, B, C, D. A gives an idea, then B gives an idea. So, A and B are combined, then C gives a third idea, A, B, C are combined, then D gives a fourth idea building on A, B and C. So, A plus B plus C plus D. So, it is a process where you combine, you build and you develop the ideas. So, you have some substantive input and you can use direct analogy, you can use personal analogy or comparing analogy to explain your ideas. So, you can use some analogy with some situation you have or story from your life. You can create an analogy with some similar functioning system, or you can compare with against some other system and explain the difference, and that is how your exploration process keeps going, and you try to combine these ideas to create a solution to a problem. So, a group tries to work collectively towards a particular solution rather than generating a large number of ideas. So, you do not try to get 50, 60, 100 ideas, you work with a limited number of ideas and you work collectively. And because you are adding A plus B plus C plus D, often you will find that A plus B plus C plus D does not mean anything. Okay. So, therefore, a synectic session is much longer than brainstorming and much more demanding. Whereas a brainstorming session, you can just start with let us say a whiteboard, you can place post-it markers, then you can group them, okay, and by doing that you can come up with solutions. So, in the synectic session, the group is encouraged to use particular types of analogy. So, when you are talking about your solution, you can use 3 different types of analogy: direct analogy, personal analogy and comparing analogy. So, here is an example. So, we will see how analogy works here. You can see here on the right, this is a forklift truck. So, conventional forklift trucks have to face head on to the stacks. Okay, and imagine the Amazon warehouse where there are lots of different components, they are all stacked row after row after row, and you might have some forklift trucks that are moving around, and these are placing and lifting pallets, and they are maneuvered again within the aisle between the stacks to move to another location or exit the warehouse. So, that would require these trucks, because they have a width, they have length and they also have a height. So, due to that, if you had to pick up things from different locations, you would have to move the whole truck to face that item. So, that would normally require the aisles to be quite wide, and that would use all of the space in the warehouse. So, you can use a personal or a fantasy analogy as such. If you say in your synectic session, if I was holding the pallet in my outstretched arms going along the aisle, I would like to be able to twist my upper body through 90 degrees to place the pallet in the rack. I do not want to move my entire body, just twist my arms. So, that is a personal analogy. Now, that personal analogy can be converted into an actual physical mechanism. So, here you can see the forklift truck remains at the same place, and you just have this outstretched arm which can be rotated around, it swivels around here. And so, you need much less space between the aisles. So, you just need to swivel this around, you do not need to swivel the entire truck around. So, the driver stays at the same location and just this thing swivels around. You can also use symbolic analogies. For instance, you can use a rotating turret or an articulated skeleton. So, you can use rotating turrets or articulated skeletons as analogies to what you might implement. So, using such analogies, you come up with this design, which is an articulated truck with forks which are mounted on the front section. So, this is the front section of your truck and they are mounted on it, and this can swivel through 90 degrees. So, you understand how to conduct a synectic session, and you understand the difference with the brainstorming session. So, these creative methods help you enlarge the search space. They enable you to transform, move the search for a solution from one area to another. They use random input, human beings who come in, and you can also use stimulus from let us say opening a book or dictionary or TV. Okay. So, they are not systematic techniques. So, let us say you are moving around, you see something in the outside world, or you just go to a random channel on a TV, you see something and you use that analogy to solve your problem. So, that is a creative method. So, let us say you are working on a problem and in the evening you are watching TV and something you watch and that generates some idea in your head. That is a creative technique. Your brain is working creatively. It is applying the solution in some other space to another space. So, in carrying out your creative methods, you often ask the question why over and over. Why is this device needed? Why can't it be eliminated, etc., etc. So, the process of asking why will help you solve the problem. You can also carry out counter planning, which is pitting one idea against the opposite. So, you are sitting down to discuss 4 people and you have 2 really good ideas, seemingly everyone agrees they are 2 good ideas. So, you can just create, you can draw a chart. So, you can write the 2 ideas and list the pros and the cons, and then as a group decide which idea might have a better chance of succeeding. So, see the pros and cons and pit the one idea against the other. So, if you go with this idea, this is the spec you will end up with. If you go with this idea, this is the spec you will end up with. Okay. Which one is better? So, maybe there are 10 specs that you are trying to get to, and of those 10 specs, one idea is winning on 6, another idea is winning on 5. So, then the one idea that is winning on 6, that is the one that wins. Alright, so those were creative methods. Now, let us talk about rational methods. These are formal techniques which also you can use in the context of your practical project. So, that consists of identifying opportunities. We have looked into identifying opportunities in the past classes, and then going into clarifying the objectives. Once you have identified the opportunities, you can clarify the objectives of solving a challenge problem. You can then establish some functions which are roles, responsibilities, etc., or functions of individual parts, components, etc. And then you can set requirements. So, clarify the objectives, establish the functions, then set requirements, determine the characteristics of your product, generate the alternatives. Okay, this is also known as concept generation, and then concept selection or evaluate the alternatives. Okay, then improve the details, and that is how you can go about solving a problem. Other research methods include market analysis. So, market analysis is typically trying to understand what is my market size. Let us say tomorrow you want to launch your own product. So, what do? You want to find out for this product that you are launching, okay, you want to make a profit, of course. So, you want to understand, well, how many units can I sell, and that will depend on the market size. Let us say you are targeting 100,000 units a year, and maybe you are selling in to a population of 10 million. Is this realistic or not? Will 100,000 people in a population of 10 million want this product or not? Then once you have got your market size, you also want to be thinking, well, this will be the chunk of the market that I will get. then how can I grow it? What are the current trends in the market for these sorts of products? So, let us say smartphones, you want to create a new smartphone for 5,000 rupees, 5G smartphone. So, what is the likely market growth? Can I grow 10% year on year? Is there a trend towards buying these sorts of smartphones? Which sorts of customers will need it? Will it be the youth, the elderly, the kids? Okay. Who are your competitors? What is the business environment that you are operating in? So, all of this information, this market analysis you can do using different sources such as technical and trade journals. So, technical journals, for instance, you can go to research and engineering design, you can go to journal of manufacturing process, you can go to science, nature. So, those are journals, and there are trade journals as well, which are specifically to do with business. Okay, look at those. You then go ahead and look at abstracts from these, from the articles in these journals. Okay, just the abstract, that tells you a lot. Don't have to read entire papers. You can look up research reports. So, at the beginning of this course, and you might have seen the resources section on Hello IITK, I have posted some white papers. So, those are research reports, okay, company research reports. Have a look through those, and that will give you some ideas about market size, market growth, market trends, etc. You can go to technical libraries such as our Calcul library. You can look at catalogs. So, if you go and look at the catalogs of suppliers, then you can find out what components are available, and that can help you again decide how you will create your product. So, let us say for the Bytronics assembly system, you need a lot of sensors. So, what sorts of sensors are available? You will find that from the catalog of the suppliers. So, for instance, I encourage you to go up the website of RS Components. RS Components is a seller of motors, encoders, sensors, etc. So, you can look up their catalog and see what it looks like. How are the different parts specified, etc. You can look up patents. Okay, patents will give you an idea of where the current market is, what are the latest products that have come out. You can of course use the internet as well. So, there is primary research that you can do, and there is secondary research that you can do. Primary research is usually research that you conduct yourself, not something that anybody else has done. You yourself go out in the field and conduct the research. So, for instance, surveys, interviews, focus groups, observations, all of these constitute primary research. So, if you send a survey out to 100 people or the campus community, of course, with the right permissions, so that constitutes primary research. And these surveys these days can be very easily conducted. You do not have to print out pages and pages of paper. You can just create a Google form, for instance, and you can send that survey out using a web link. You can invite people to take part in interviews. Very often such interviews you will need to pay people to give you honest interview. So, that is also primary research. So, you are interviewing somebody to get their opinion, or you can create a focus group. So, you can call in 10 people from chemical engineering, let us say, to give you some ideas about what would constitute a good desktop chemical engineering factory. So, that would be a focus group. Or you can go out and make your own observations. So, let us say you want to improve the area around the IIT campus, okay, and you want to find out what are the problems. So, you step outside the campus and you find out, maybe you want to improve the sanitation and hygiene in the localities. Then you go out and find out how many bins are overflowing, where are the locations where people are dumping their garbage, pictures. Those will constitute your observations. Okay. So, that is primary research. Secondary research is research that you can carry out using the internet, using your literature, and using case studies. So, anything that you do that is already done by somebody else, you go and find out and use that information, that is secondary research. You can do a literature search. So, for your project you can go on Google Scholar, you can go on Engineering Village, you can go on Science Direct, okay. You can go directly to the websites of different journals, okay. So, that is literature research. You can also carry out case study research. So, people have done lots of case studies in the past, you can look up these case studies, and that will also constitute secondary research. So, primary research, the researcher participates directly in the data gathering process, collects first hand information himself or herself, which serves as research materials for the systematic investigation. And in secondary research, the researcher relies solely on existing research materials, only existing research materials which other people have carried out, but you are using that to inform your discovery phase. Again, there is qualitative research that you can carry out, and you can also carry out quantitative research. Qualitative research is a process of collecting, analyzing and interpreting non-numerical data. So, data that is not numerical in nature. So, for instance, text, video, photographs, audio recordings. So, all of that is qualitative research. So, to improve the sanitation hygiene around the campus, you go and take some pictures. Just outside the campus, when you go out, you see some things that are amiss, people have dumped their garbage, you take a photograph, that is qualitative research. Diary accounts and in-depth interviews, okay, again there are no numbers associated, so that constitutes qualitative research. If you look up people's diaries or you conduct an in-depth interview, that is a qualitative research. It is also primary research. But this for instance, photographs, audio recordings, if you have taken them from some source such as the internet, it might be secondary research. So, you can see qualitative research can be both primary and secondary, and likewise quantitative can be both primary and secondary. So, you might carry out content analysis, you might carry out some thematic analysis. Okay. So, you might use software tools. There is a software tool known as NVivo that is used for qualitative data analysis. So, there are many such software tools for qualitative data analysis. What you do there is you take in all this data and then you may create nodes, for instance, and sub nodes, and these relate to themes. Okay. So, some theme and nodes and sub nodes, and you group them. You mark out little bits of text. So, all of that is feasible using software tools today such as NVivo. So, that is qualitative research. Quantitative research involves objectively collecting and analyzing numerical data, and so there are numbers involved. So, you collect some numerical data to describe, predict or control variables of interest. So, you collect this numerical data, it may be from your own experiments, it may be from information that you get from research that other people have done. Okay. So, these sorts of numbers, this numerical data that you collect, that helps you test causal relationships between variables, whether one variable is related to another. So, let us say the livelihood of people, if they are poor in the campus outside, then they probably do not have bins of their own, so they do not manage their garbage. How does that translate to the volume of garbage they dump? So, you might test some kind of a causal relationship like that, or you might be able to plot a graph, the quantity of CO2 that is pumped in the city of Kanpur into the atmosphere, and that against the location of the refineries or the numbers of refineries, and then that would be a causal relationship between variables. Okay. How does one variable affect another? So, that is possible only when you have numbers. So, you can conclude one way or the other, you can see a correlation, and based on that you can make predictions and you can generalize. So, based on these graphs, these regression equations that you come up with, let us say you come up with the line of best fit, you can use that to make a prediction for the future, and you can generalize the results to wider populations as well. So, numerical data enables you to do forecasting, for instance, whereas qualitative research gives you information that is not very objective. It is subjective interpretation of data that you can also use to define your challenge problem. So, typically in quantitative research, many statistical analysis tools are used. So, if you have heard of some statistical tools, examples are SPSS or Minitab, etc. So, these tools are software tools that can, or Excel as well, very simple quantitative research tool would be Excel. So, there you can go and plot, you can analyze the effect of one variable on another, and so on and so forth. Yet another research method is creating a user persona, and this is crucial because when you are trying to define your market segmentation, you are trying to understand what your market for the product is going to be. You want to be understanding what are the different types of users that you might have. For instance, you might have Mark, who is 22, Justin, who is 31, and Maggie, who is 52. And below that, you can write some details about their demographics and their behavioral identifiers. So, these personas help you make your marketing more customer centric. They summarize a number of typical customer types. So, you might have 3 different types of customers that might use your product. One is a male in the 20s, one is a male in the 30s, and maybe a female in the 50s. And what might be their behavioral traits. So, you will be able to create a number of typical customer types that you may provide your products and services to. So, for instance, if you are creating that IoT product, you might be able to think of, well, this IoT product will cater to these sorts of user personas. So, that way you can document, well, I'll be able to reach out to this much segment of the population, hopefully. Okay. And also your marketing can be more customer centric. So, based on their behavioral traits, you can maybe come up with catchy slogans, you might come up with certain advertisement campaigns that might be catering to those specific user personas, so that they are attracted to your product. So, you can use them to make your design more relevant also. So, how can you make your design relevant to 3 different types of customers? So, these personas, these things, these demographic details and the behavioral identifiers, they can include typical background to the customer's life, their interests, their needs, their interaction with the products, and much more. So, what is their life like, what sort of profession they have, okay, for instance, and based on that, what are their interests, or maybe not based on that, what are their interests, what are their needs, what do they really need. So, what does this person in the 20s need out of your IoT product? What does this lady in the 50s, what use could she make? Maybe she has some disability, maybe she can make use of your product to navigate the world better. Maybe she has a need for connecting to a larger number of people in her family. So, these customer needs can be captured in these user personas, and also they make your interaction with your products. So, they define the interaction they will have with your products based on their persona. We talked about interviews as being a method of carrying out primary research. So, interview is nothing but a qualitative research method, and it relies on asking questions in order to collect data, and usually it involves at least 2 people, of which one is the interviewer asking the questions. There might be more people as well. So, there are different types of interviews that you can conduct. So, you could conduct structured interviews where you have predetermined questions which are asked in a predetermined order. So, 10 questions which you will ask to all the people that you solicit an interview from, or you could have free flowing, semi structured, or in between interviews. So, you just want to capture some knowledge about a topic, you go out to the microphone and you ask different people, and or you sit down and just have a free flowing conversation and a chat. And that is another type of interview, free flowing or semi structured. There are some questions, and there are some questions that flow out of the response that the interview gives you. So, really looking back again at the double diamond, what we are doing is we are ripping the brief, we are clustering the topic, we are doing a primary research and secondary research. So, today you learnt a lot about primary research and secondary research, and what it leads to is these unstructured research findings. So, you have got a lot of data that you have collected in sheets of paper or maybe files on your computer, but you have not given any structure to them. So, these are your unstructured research findings, and then you must go ahead and converge in the next phase, which we'll discuss later. Okay. So, really in the discovery phase, you are carrying out your market research, you are carrying out your user research, and you are analyzing your existing solutions. So, you learnt these market research techniques, you learned these user research techniques today. So, you need to unpack these to form your subtasks. So, one of the things that you might have noticed is the importance of sketching. So, sketching is so crucial to creating a final product. and that is often underestimated. So, you may need to create 50, 100 sketches until you get to that final concept that will make it to the market. Okay, so a lot of patience and perseverance is required to create a really world class product, and that is what you should that is the message you should take home from this class actually, that you need to persevere and work really hard to get to that product which can beat the competition. Okay. So, as sketching is important, the next topic that we will talk about is a bit of sketching and engineering drawing, and we will probably do that in the next class, because we need some time to also navigate to our design studio here. So, just like you saw the Calty design studio here, it will be useful for you to just go and have a walk around our design studios and the workshop and just get a feel for what you can do. Okay. So, we will end here. So, thanks everyone for coming to this class.
Hello and welcome to this piece of literary snippet. Perhaps the most popular literary genre after novel is the short story. Sharp, compact narratives whose charm lies not only in what is said, but also in what remains unsaid. Today I will be reading one of the shortest instances of a short story that I have ever encountered, and indeed the very charm of this particular story that I am going to read out today lies in the way it abruptly ends. It is an ancient tale from Mesopotamia which has been retold by several authors, among whom the name of Somerset Maugham stands out. The adaptation that I will be reading out is perhaps the closest to the one that Maugham wrote. The story is titled, in all of its adaptations almost, as Appointment in Samarra. Here is the story. A merchant in Baghdad once sent one of his servants to the market. The servant was supposed to buy provisions for the merchant, but when he returned, he came back empty-handed. Indeed, the servant had all gone white, and trembling with fear, he told his master that he had met death in the marketplace. When I entered the market, the servant said to his master, I was jostled by a woman, and when I turned to look at her, I saw that she was death. I am very scared, master, because death looked at me with a threatening gesture. Can you please lend me your horse so that I can fly away from Baghdad to the town of Samarra and thereby escape death? The master, being a good man, gave his servant his best horse and saw him gallop off to Samarra to escape death. Then the master himself went to the marketplace and confronted death. Why did you make a threatening gesture to my servant? Asked the master to death. And death replied, it was not a threatening gesture. Rather, it was a start of surprise. I was astonished to see your servant here today, because this evening I have an appointment with him in Samarra. See you in the next episode of Literary Snippet.